Why waste time in commute and spend a lot of money for NEET UG coaching? Parents, do you want your kids to achieve top scores in NEET? India's leading online NEET coaching, 100% success. NEET UG. TeenEinstein.com. At TeenEinstein, we focus on NEET coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany and zoology with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry and biology for rigorous practice, concept understanding, evaluation, quizzes and thousands of videos. Limited offer, 40,000 per year. Book your class. TeenEinstein.com. Contact 99402 49720.
Hello students, welcome to the POQ discussions on JEE Advanced papers. Here I have got a problem from JEE Advanced paper 1 2022. The question says a medium having dielectric constant K greater than 1 fills the space between the plates of a parallel plate capacitor. The plates have large area and the distance between them is D, as you see in the figure 1. The capacitor is connected to a battery of voltage V as shown in the figure A. Now both plates are moved by a distance of D by 2 from the original positions as shown in the figure B. So initial configuration of the parallel plate capacitor is this one. This is the material or the medium which has dielectric constant K greater than 1, and the distance between the plates is D, and the plates of the parallel plate capacitor are connected to a battery of voltage V. In the second configuration, in the figure B, both the plates are moved away from their original position by distance D by 2. So this is the second configuration. Now the question is, in the process of going from the configuration depicted in figure A to that in figure B, which of the following statements is or are correct? So these are the options. So there could be multiple options correct. We have to verify which one is going to be correct and which one is incorrect. Okay, so let us see the first option. The first option says the electric field inside the dielectric material is reduced by a factor of 2K. So first of all, what is the electric field in this first configuration? If I write electric field, say this is EA, that can be written as sigma by K epsilon naught. In other way also we can write the electric field is equal to V by D, because the potential of the battery is V, which is connected across the capacitor. So this way also I can say. Now in the second configuration I have, see, this is the medium, material medium. Let me write the potential difference between these two ends, or this space is given by E0 into D by 2, because this distance is D by 2, and also this portion has potential difference of E0 by 2 into D. Then this place will have electric field E0 by K, and multiplied by d, this is the potential. Okay, so look here, V will be is equal to E0 into d by 2 plus E0 by k into d plus this one E0 d by 2, right? Now see, this is E0 d by 2 into 2, so this will give you E0 d. If I take E0 into d, then I get 1 plus 1 over k, right? Then E0 d by k, this is k plus 1, right? See, now this portion I can write, see, if I just divide by d, this left hand side, okay, let me just go to the next page. So I have got, so far V is equal to E0 into d by k whole into 1 plus k, right? So here if I divide this with d, then I get E0 by k whole into 1 plus k, right? And look, this is the electric field inside the material, right? And this is the electric field, this is also inside the material, but this I have taken as, suppose, E1, okay, as I had written, let us say that is EA, right? And now this I'll write as EB. So look, EB into 1 plus k or k plus 1, whatever you can write, that is equal to EA, right? Then I get EB is equal to EA by k plus 1, right? Therefore I can say the electric field is actually reduced by 1 plus k times. At least we can see that the electric field inside the dielectric material is not reduced by a factor 2k, right? So this is then not a correct answer or correct option. Now the second option, let us see. We have to find out the capacitance. In the second configuration, here it is said that the capacitance in the second configuration will be decreased by a factor of this 1 over k plus 1. We have to check now the capacitance. So you know this configuration, I'll just clean everything. See the capacitance for this, if I say this is CA, this will be K epsilon 0 A by D, okay, with a dielectric material having dielectric constant K inside or in between the plates of the capacitor. Now see, I have total thickness now 2D. For the second configuration in the figure B, this distance is 2D, but some thickness, now I can actually consider that there are 3 dielectric materials which are inside the space between the plates of the capacitor. This is medium 2 and this is medium 3. And if I know the thickness of each of them, or if I know the thickness of this dielectric material, then see, generally we have learned this, if I have parallel plate capacitor, and the space between the plates is filled with a dielectric slab of same area but thickness T, where as the distance between the plates is D. In that case, the capacitance is generally written as C, suppose CB is equal to A epsilon naught divided by D minus T plus T by K, etc., etc. Okay, so this is how we do in general. Okay, this in this kind of cases. So here look, this D is 2D and thickness of the dielectric material is D instead of T. So if we put those things here, look what I get. For the original configuration given for the problem, is the dielectric material has constant. For the given problem, I can write this as 2D minus D plus D by K. Okay, now look, this is becoming A into epsilon naught, this is D plus D by K, right? So this will give you A epsilon 0. If I take D common, then I get K plus 1, and in the numerator K will be multiplied, right? So look, this one epsilon 0, K epsilon 0 A by D, this is nothing but CA into 1 over K plus 1. Therefore I can see that CB is becoming CA divided by K plus 1. So the second option, look, the capacitance is decreased by a factor of 1 over K plus 1 is correct. Okay, so this option is correct. Now let us see the third option. The voltage between the capacitor plates is increased by a factor K plus 1. Let me tell you one good thing over here. See, in this case, the plates of the capacitors are actually biased by a battery of constant voltage V. Therefore, the potential difference between these plates will be always V. It cannot be exceeding V. Okay? It cannot be exceeding V. Therefore, in this case also the potential difference will be V only. Okay? So the third option, the voltage between the capacitor plates is increased by a factor, this is not correct. Now the last option, the work done in the process does not depend on the presence of the dielectric material. Let us now deal with this. Let me clean this space. So we have seen this is not correct, this is correct, this is also not correct. So now the work done. We know the potential energy, right? Potential energy stored by a capacitor of capacitance C when the capacitor has potential difference V across its plates is half C v square, right? And when we have to find out work done is nothing but change in the potential energy. So in this case I can write work done is equal to UA minus UB, change in the potential energy. Okay, UB. So this will be the potential energy. Okay, look, then I can write UA I can write half C1 V square, potential is constant, and in the second case it is half, this is CA, this is CB V square. So half V square is common. I have got CA minus CB. We know CB will be equal to CA divided by K plus 1. So I can take this CA common, then I get 1 minus 1 over K plus 1, right? So this will give, see, this will give half CA V square, this is K plus 1 minus 1, so K divided by K plus 1. So I can see one thing, that the work done in this process is not independent of the dielectric material present inside the capacitor. Okay, so the work done in this process is dependent on the dielectric material inserted between the plates of the capacitor. So the fourth option is also not correct. So this B option is alone correct over here, and this is the answer for this question. Thank you.
Why waste time in commute and spend a lot of money for IIT JEE coaching? Parents, do you want your kids to achieve top scores in IIT JEE? India's leading online NEET coaching 100% success IIT JEE. At TeenEinstein, we focus on IIT JEE coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany, and zoology, with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry, and biology, for rigorous practice, concept understanding, evaluation, quiz, and thousands of videos. Limited offer 40,000 rupees per year. Book your class. TeenEinstein.com.